So because it's the set of all points, right, and we're going to have some point, and it's actually going to be in the middle of your parabola, and you're going to have some line, but neither one of those are actually on your parabola. They just help us determine the shape of your parabola. So did any of us ever do constructions in geometry where you actually had to like build the shapes out of like certain characteristics and things like that?
I'll give it to you.
Should have been.
Well, I don't know if it's going to look like on the
I'm talking about like your geometric shapes. So you can also do a similar idea with your like parabolas if you get like string, and you have to make sure that like the string is a certain length because you want it to be an equal distance from a given point in a given line. And if you were to create the shape that you're going to end up with is a parabola. Now, we're used to looking at parabolas that look something like that, either going up or going down. Okay? Like I said, your focus is going to be a point that is inside of your parabola, and it is going to be lined up with the vertex of your parabola. And then we also have a directrix, which is the imaginary line that we're talking about. So your fixed point is called your focus, and then your fixed line called your directrix. Now, both of those are imaginary. They're not actually a part of your graph. You just use them to find the graph. So, if all points on my graph have to be equal distance from this point and this line, agreed? Yes? Then what has to be true about my vertex? Yeah, because notice that my graph is not super drawn to scale, but my vertex is a point on my graph. So that means that this distance right here and this distance right here would have to be the same because they're the same distance from your point and your line. It just happens that when we're at our vertex, it all kind of lines up, which makes it nice. Okay. Are we all kind of with me on the idea of what we're looking at? Now we're going to get into more of the equation type stuff. Okay. So the standard form equation of a parabola with the vertex h comma k is as follows. And we have two. We have x minus h quantity squared equals 4p times y minus k, or y minus k quantity squared equals 4p times x minus h. So if your x is what's being squared, remember that that's when we have a vertical or up and down parabola. When our y is what's being squared, that's when we have a horizontal or a left and right parabola. Okay, so a couple of things to point out. So your vertex is going to be at h comma k. Your directrix is at y equals k minus p, or x equals h minus p. Okay, and your focus is also going to be p units away. So basically what that means is that this distance right here, we're going to label as p. And then it also gives you, if you know that your center, your vertex is at 0, 0, we can plug in zeros for our h and our k, and you just end up with those bottom two equations. You don't really have to know that because we get it if we plug in 0, 0. So. Now, for your test over these, I will be giving you all of the equations. However, they will not be labeled. So you have to know them well enough to know like which one goes with what. And remember that this is our first conic section. We're also going to go over ellipses and hyperbolas. I'll also give you their equations, but again, not labeled. You need to know which one goes with which. That down. Alright. So here we have some pretty pictures. You don't have to write all this down. It's kind of a lot. It's just kind of showing you an example of both a vertical, so either going up or down, and then also a horizontal, so going left or right. So like I said, remember that our focus always has to be in the inside of our parabola. So that is going to be a good indicator of what direction our parabola is going to open. Your directrix always has to be the opposite direction, away from your focus. Now notice that with our up and down parabolas, our directrix is a y equals equation because it's horizontal. With our horizontal parabolas, our directrix is an x equals equation because it's a vertical line. The only other thing that you need that wasn't on the previous page is your focus equation. And your vertex is always h comma k no matter which direction it is going. So, any questions on that? Yes.
What was that x squared equals for p y formula on the slide?
This one?
No.
This one? No. Those are only two equations.
The one.
The bottom two?
Yeah.
Like I said, that's just if I plugged in 0 for both h and k.
Okay.
So, like, if you're at your origin, your h and your k are going to go away. So I would just get y squared equals 4p or times x, or x squared equals 4p times y. But like I said, you don't really have to know those because you can get them by plugging in 0.
Okay.
Does that make sense? Yeah.
Wait, so the line from the focus to the directrix is called what?
P value. It's not.
Just the p value?
Yeah, it's not necessarily like the line isn't labeled that. That's just how far away it is.
Okay.
And it has to be the same distance. So the distance from your vertex to your focus is p, and then also from your vertex to your directrix is also p because they have to be the same distance away. Other questions? It's alright, I'll answer.
How do you know which way
Given what? If you're given an equation, then if it's an x squared, it's going to be up or down. If your p is positive, it'll be up. If it's negative, it'll be down. If you have your y is what's being squared, it's going to be left or right. If your p is positive, it's going to be opening to the right. If it's negative, it opens to the left. If you're just given, we're going to look at an example like this in just a second. If you're just given, like, say your vertex and your focus, well, remember that you always have to open towards your focus. So then I know I have to open towards that point. If you're giving your vertex and your directrix, well, you know your parabola has to open away from your directrix. So then you know which way it comes. Does that kind of make sense? And then if you were giving your focus and your directrix, you know that your vertex has to be the midpoint between those two things. And then you know that it has to open towards the focus. Does that help?
Yeah.
Other questions? Alright, so let's look at an example. So it says find the standard equation of the parabola with vertex at the origin and focus at 2, 0. So what might it be helpful to do first? Well, yes, but before we do that. Yeah. So usually when we're talking about our conic sections, we're going to draw a rough sketch because that's going to help us know which equation we want to use. So they help us and tell us that our vertex is at the origin, and then our focus is at 2, 0. So which direction from my vertex is my focus? To the right. So which direction is my parabola going to have to open? To the right, because my focus has to be on the inside of my parabola. Okay. So which equation am I going to be using? The one with x squared or the one with y squared? Y squared. Okay? So remember that that one is y minus k quantity squared equals 4p times x minus h.
Sorry.
But what did they tell us our vertex is? At the origin, which is at 0, 0. So what do we know that h and k are? 0. So this just becomes y squared equals 4px. So if we have already found our h and k, then what's our last variable that we have to find? The p value. And we said that p is the what? So this is going to be my p value, which in this case is going to be what? 2. So am I just going to put a 2 in front of my x? Y squared equals 2x? No, I have to put the 2 in the place for my p value. So what does it become? Y squared equals 8x. So be careful because that's a lot of people's mistakes that they just want to stick the 2 in front of it without multiplying by 2. Remember our equation has 4p, not just a p in front of the x. Questions on that? Correct. Exactly. Right back. Alright, so this one says find the focus of the parabola given by y equals a negative 1/2 x squared minus x plus 1/2. So what do we notice about our equation? Okay, so what type of parabola do we have? It's going to be vertical, up or down. Specifically, which direction is it going to be? Down. down because our a value is negative or less than 0. Okay, but what else do we notice about our equation? We don't know what the vertex is because what form are we not in? Vertex form. So we're not in vertex form. So what do we kind of need to know or do in order to figure out our vertex and our p-value? We need to put it in vertex form. And how did we talk about doing that? Completing the square, right? Same process here. Now, something we should also notice is what do we have inside of our equation? Fractions. We all tend to do well with fractions. Not really, no. I wish that wasn't the case. And also remember, what's the first requirement of our completing the square? We have to make the a value what? Positive and what? 1, right? That's why we had to factor out the 7 on our bell word. So in this case, we could factor it out, but because I also have a 1/2 at the end, and both of these happen to be 2, I'm going to go ahead and multiply everything by a -2. Am I allowed to do that?
Yes.
As long as I do what?
Multiply the other side by negative 2.
Multiply by the other side by -2 as well. And that's going to make my life a whole lot easier. So that's going to give me negative 2y equals x squared plus 2x minus 1. So then, remember that for our last one, we actually had the factor, but since this time we multiplied, I'm just going to group my first two together. Agreed? And what's our goal? What are we trying to do here? Not square it. What do we want to make it? Base squared. Completing the square, right? Well, what's our goal when we're completing the square? To make a perfect square, right? We want it to be like parentheses square. And right now, if we factored x squared plus 2x minus 1, first off, that's not factorable. And second off, it doesn't factor to a perfect square, which is why, yes, we have to complete the square. Now, how do I figure out what's missing from the inside in order to give us a perfect square? Like that number. Do you remember? So yeah, we're gonna have to do a times c, so it's gonna have to multiply together to give us that adds together to give us our b value, and we want them to be the same thing, yes? So if the same two things have to add to give us that term, what could we do in order to find it? Not by b, but by, so I have something plus something equals 2, right? That's the same thing as having 2 of my somethings, yes? So how do I get rid of the 2? Divide by the 2, right? So in general, we know that it's going to have to be b divided by 2, right, to work our way backwards. However, what do I have to do to get this value then? Not by 2. Remember, it's what times what gives us this.
By one.
Not by a. So remember, in the end, my something, or whatever I'm trying to find, is this number right here. So this times itself has to give us that. So in our case, b is 2. So b divided by 2 gives us 1. 1 squared is 1. Okay? But what do we also have to do? Subtract a 1 on the outside in order to balance our equation. So now, what does x squared plus 2x plus 1 factor to? X plus 1 times x plus 1, which is the same thing as x plus 1 squared. And minus 1 gives us negative 2. Now, remember that now we're dealing with our conic sections in a little bit of a different light. Because normally when we had quadratics, we would have divided by a negative 2 and had negative 1/2 x plus 1 quantity squared minus 1. And that's how we would have left it. But because we're wanting it to be in the conic section vertex form, right? Let's remind ourselves what that looks like. So, we have x minus h quantity squared. That part's okay. But notice that I don't have any numbers on the outside with it. We need to move that number to the other side to be with our y value. Okay? So for us, that is a negative 2. So what am I going to do? We just want to move the negative 2 over. So what do we need to do? Add 2. So then we're almost there. Okay? Because remember also that it's supposed to be like some number, which is going to be our 4p, then it's parentheses x minus k. So how do I like move my negative 2 out to the front of a parentheses? Factor it out. So I would have negative 2 times y minus 1 equals x plus 1 quantity squared. So, what is our vertex here? Check your formulas. There we go. Negative 1, comma 1. Because they're in parentheses, we have to flip our signs for both of them. But they ask us to find our focus. So what would we need in order to be able to find the focus? The p-value, right? So where would I get that from? Okay, alright. Well, we know we're looking for the p-value. Where was the p-value located when we looked at our equation? Yeah, it's in front of the y minus 1, but does p equal negative 2? No. What equals negative 2? 4p equals negative 2. So remember, like we said on the other past one, our p-value is not just what's in front. It's 4p. So how would I work my way backwards to figure out what p is? How do I solve for p? Divide by 4 and we get negative 1/2. Okay. So then we know that that's how many units away from our vertex that our focus is going to be. Agreed? But we need to decide which direction away that it is. So which way did we say that our parabola is going to face? Down. So that means that remember that our focus, since it's on the inside, also has to be below our vertex. It has to be below our vertex, specifically by negative 1/2. So which of these am I going to subtract 1/2 from in order to put it below my vertex? The y value, right? Because y is what determines your up and downness. So for our focus, we would have that it is at negative 1, comma 1/2. that would be questions on that one. So we're going to need to make sure that we know how to complete the square, because we're also going to have to complete the square with our next two as well, conic sections. So we're going to be doing a lot of completing the square. And we're not super great at it yet. We'll get there. So let's look at one last example. This one says, find the standard form of the equation of the parabola with vertex 2, 1 and focus 2, 4. Then write the quadratic form of the equation. I'm not really worried about this last part, because basically all you have to do is multiply it out, okay? Most of the time we're not going to want to put it back in quadratic form, so we're just going to do the first part. So what do we need to decide first? Agreed. So what might it be helpful to do in order to figure that out? Draw a picture. We like pictures. And so what quadrant is my vertex in? The first one. And where is my focus located from my vertex? It's above it. So which direction is my parabola going to have to open? Up. So which equation am I going to use? The x squared one, so it's x minus h squared equals 4p times not squared. So only one of them can be squared in order for it to be a parabola. So do we know our h and our k value? Yeah, what is it? Alright, and then what do we need to find? What's left in our equation that we still need to plug in? Our p value, which remember is what? The distance from your vertex to the focus, yes? Which in this case is going to be what? Now, let's say I didn't have that, or it wasn't nice pretty numbers like that is. How could we find the distance between 2 points? The distance formula. What is our distance formula? Right? We all have our distance formula. We should know our distance formula. So if we didn't know how far apart our focus was from our vertex, we can always plug into our distance formula in order to find them. But in this case, it's pretty easy to see that they are 3 units away. So we're going to have x minus 2 quantity squared equals 4 times 3 times y minus 1. So our final equation would look like that. And then, like I said, the quadratic form, which is what they ask in the second part, you would just have to FOIL out x minus 2, distribute your 12, and then solve for pi. Which I know that all of y'all are capable of doing, and most of the time, we don't want it in that form anyway. So we're just going to leave it like that. Questions on that?